So today we're going to talk about a subject that kind of drives me crazy, which is acoustical doors. And our experience over the years, we've designed a lot of projects, we've worked on a lot of projects. Acoustical doors don't work properly in the field quite often. Now, the ones that we tend to specify are magnetically sealed, and they tend to work quite well. The ones that are compression sealed, however, don't. And what's happened on a lot of projects is other people have chosen compression sealed doors, or they've been brought in as substitutes on projects. And then when we get in to do final testing, we find they're underperforming. Most recently, I was testing a project for an architect that we did not design, but it was a compression sealed door substitute for a mag sealed door. And it was testing at 38, supposed to be a 50. The reason being that the door could not get enough compression to seal the seals. And that is because they were using a card swipe access system that would not allow that amount of compression. So it was testing worse than usual. This was testing, I think, around 34 when we started. It got a little better with the contractor doing some messing around with it. But the best it ever got to was about 43. So you're paying for 50 and you're getting 43, which is a dramatic loss when you get down to isolation. And in the case of this particular one, it's a vocal isolation booth, so it was kind of a big deal. I don't know if they're ever going to do anything about it, because we told them what they needed to do was change the seals out to magnetic, which can be done in the field. It's an added cost. Obviously, contractors involved. So what I want to talk about is why magnetically sealed doors are used. And first example is your refrigerator. Your refrigerator has a mag sealed door on it because you want to keep the cold in, you want to keep the heat out, and acoustics are the same thing. So when a magnetically sealed door frame, like a refrigerator, reaches out and grabs and closes, that's keeping the door closed. Now, in the case of a door that's used by the public, it has to meet ADA requirements. So you have to have a door that can have the proper opening effort to meet ADA. And there are some that do, and there's some that don't. When you get beyond about STC 48 or so, 50, you have to go to a double magnetic seal, and most of those are not going to meet ADA requirements and would require like a motorized operator or something to open the door. But if you want high performance doors, you're going to be into double or triple magnetic seal doors, and they are not going to meet ADA, so they're not always usable. We've had some clients who have chosen to go with compression seal because of the opening force, but they never are even 10 dB low. They're usually more than that, 10 to 12, sometimes 14 dB lower than their rating, because it just can't work. So let's take a look at a door here online, kind of walk through the way it's assembled and the type of performance that you can expect out of it if it's properly installed. Our base spec is always based around IEC Acoustics, and that's because of our experience with them in the past. This particular door is an STC 43. It's an acoustic door that we have had field performance closer to 47 from this door. Now, they won't rate it that way. That's because they're very conservative. But we've had a bunch of these out in the field for quite a while, and they not only have performed higher than the original rating, but they've also continued to perform in the future. There's a number of things about the way they build their doors. Now, first of all, they're built completely assembled with hardware delivered. So they basically set the door in place to the threshold and the walls, and it's done. There's nobody putting any hardware in the field. There's nothing else going on. This door uses a cam lift hinge system, so the door rises up in the air as it's opened so that it lets this compression seal at the bottom expand and then get compressed as it drops. You've got the magnetic seal around the perimeter, which in the case of theirs, it really is a very high performing seal. I'm sure there's other ones that are good too, but we found that this is the one we prefer. And you've got the compression seal combination. You get a performance that tends to stay over time. Self-aligning magnetic seals, split frames so that you can easily install these in the field. So you get a very clean installation. And in our experience, their doors tend to meet spec when they're installed. They don't tend to be drifting. Let's get this back here. 43 is, and we'll say it's 43 to 45, is fine for a lot of applications, but when you need something beyond that, now you're going to be getting into a double magnetic seal door. Now the negative to this has to do with ADA. The 43 meets ADA requirements for opening according to most architects we work with. Interpretation of that is a little different from firm to firm. But this double magnetic seal takes a fair amount to open. So it's kind of like your refrigerator. When you go to pull it open with a single magnetic seal, most people can open it no problem. If you had a double magnetic seal and then you add to the effort by having a cam lift hinge raising and lowering the door, you might not be able to get your refrigerator open. Just kind of like small children can't get them open in some cases, even with a single magnetic seal. But this is the type of door you get into for higher performance music spaces, recording studios, and you can go up to way beyond 51 with a triple magnetic seal. Now, the reason I think they do the double seals is when you get into these thicker, heavy doors, you've got issues with potentially leaks around the seals themselves, possibly due to the doors, and the second seal is there to close that up. Not really sure why they can't do that with a single seal with a really heavy door, but everything above 51 tends to be double magnetic seal, and then the really high performance doors tend to be triple. So I guess the word to the wise with any of this is that if you really want a compression seal door to work, you could get this door with a door at this performance level with compression seals, but you're going to have to lean on it with your body weight to close it. And then all of the tension when you do that is at the latch set. So let's go back to this just as a better viewpoint. If your latch set here is you're pushing on it and this is holding the door closed, it's not holding it evenly around the perimeter. So you're not necessarily going to get a compression seal that holds at the perimeter when all of your effort is at a latch set, which is where the mag seals come into place. The door is not being pressured to make it work. So our opinion, mag seals are the only thing you can trust. Everything else we've tested has been sketchy at best, and I've so far in testing probably, I don't know, 50 or 60 doors over the years, we've had one or two with compression seals that came anywhere close to their spec, and it just happened to be a very perfect, pristine installation, and there's no guarantee they're going to stay that way. So the door on 111 is measuring lower than any of the other doors, and this is typical of doors. This compression seal, you'll see along the length of it, here it's regressed in behind the frame. Here on the outside edge, there's this extra material that's supposed to seal it, but the door isn't actually contacting that material. And then on the back side, similar problems. We've got parts of the seal crushed down there. So in my experience, these things never really work. There's a gap in the seal right there as well, where there's a gap between the two, which is going to read through the corner of the outside. So this door is measuring 10 points lower than other standard doors with compression seals. I don't know how many of you remember old refrigerators that had handles that you had to pull to unlatch the doors. Those were compression seals, and they were the norm in older refrigerators. Modern equipment uses magnetic seals, and the reason they're magnetic is that they're able to jump out away from the frame to grab the frame of the door, giving you a good thermal seal. Acoustic seals are the same premise. You need something that completely aligns the perimeter of the door with no leaks, which is why magnetic seals are the norm of good acoustic doors. They may also have a latch set that you put a little bit of a pressure on, but even without that, the acoustic seal will work when it's magnetic. However, when it's compression, it usually doesn't. Okay, so we're going to do a simulation. And like with most simulations, this is going to be not an exact simulation. We're going to take this case here, this Nanook case from Canada, which they sent over here. That was nice of them. And inside it, we have a JBL clip loudspeaker, and we have the ability to close the lid. So we're going to pretend this is an acoustic door. And this is the noise source. So if we're looking down here, we're getting about 74 dB. And we're dealing with a case that has a compression seal. I guess I could turn this off while I talk. This has a compression seal on it. It's not exactly like the compression seal of an acoustic door, but to be honest, it works just about as well. And when it's fully compressed, it works quite well for a plastic enclosure, the simulation we're doing. And then we're going to see what happens with less than full pressure. So let's start out with our full noise source. And then we're going to close up the lid and we're going to compress it tight. So that dropped us down to about 51 dB. So that's a 23 dB reduction, which is significant. Now I'm going to release a corner of it, not fully, just a little bit of pressure off. So going from 51 to about 57, I'm going to release the entire front leading edge. So this is simulating a very small gap. When I'm releasing this this edge here, you can't really see it, but I was just releasing it from here to here. Actually turn this on. I don't know if you'll be able to see this. Never know what cameras are really doing. But we're talking about releasing the seal about a 1/16 of an inch. It doesn't take much to lose your acoustic seal. Now, that's one video.